Right, so the previous page we learned if it's a constant, the limit of a constant is that constant. That's like y equals 2. The y value is always going to be 2. We learned if it's a power function, x to the n, you can just plug in the number. We learned if it's a radical, you could just plug in the number. So what's the other rules that we can get? And these are hugely important rules. These are limit rules. And we're going to review all of these rules when we look at derivative rules, the next concept that we learn in calculus. And then we're going to revisit almost all of these rules when we learn the next concept, which is integration or anti-differentiation. So you're going to see these rules on every single test this semester. Very important that you realize what they are. So the first one says, what if the limit is x approaches c of f of x is L, and the limit is x approaches c of g of x is k. So we have two different functions. We're looking at the same x value. One of them goes to the number L, and one of them goes to the number k. So maybe like 5 and 7. So what would you do? Okay. So the first one says the limit is x approaches c of b times f of x equals b times L. What the heck does that mean? Well, I'm going to say it in English, and I encourage you to write this down. What that means is a limit of a constant times a function is the constant times the limit of the function. Let me say that again for you. The limit of a constant times a function, that would be the b times the f of x, b times f of x, that's a constant times a function, is the constant times the limit of the function. So, before we were able to find the limit as x approaches any number of just x. Well, now I can find the limit as x approaches any number of something like 5x, or negative 2x, or 1/2 x. All I have to do is take that number that's in front, like 1/2 x. I would just take the answer and multiply it times 1/2. So very easy, just pull that constant out in front. The next one is called the sum and difference rule. The limit of f of x plus or minus g of x equals L plus or minus k. So how do I like to say this? The limit of the sum is the sum of the limits. Let me say that again. The limit of the sum is the sum of the limits. Likewise, we would say the limit of the difference, difference being subtraction, the limit of the difference is the difference of the limits. So what does that say? Well, what if we had something like x squared plus 5 as our function? Well, then I could break it apart. I could find the limit of x squared, I could find the limit of 5, and then I'd just add them together. So it allows me to take long string expressions that have multiple terms in them, find the limit of each individual term, and then just add or subtract them as it's done. Number 3 says the limit as x approaches c of f of x times g of x is equal to L times k. So how would I pronounce that one? I would say the limit of the product, multiplication being product, is the product of the limits. Let me say that again. The limit of the product is the product of the limits. So if I have two separate functions and they're being multiplied, I could find the limit of the first function, I could find the limit of the second function, and then I could just multiply those two limits together. So I can break it apart, kind of like addition and subtraction. Same thing with number 4. Here I have the limit as x approaches c of f of x over g of x equals L over k. So this is the limit of the quotient, quotient being division here. The limit of the quotient is the quotient of the limits. Let me say that again. The limit of the quotient is the quotient of the limits. So what does that mean? That means find the limit of the top, find the limit of the bottom, and divide them. Well, you can do that as long as it has to be defined. So it can't be undefined. So when's a fraction undefined? A fraction's undefined when the denominator is 0. So as long as your denominator is not 0, the limit of the quotient is the quotient of the limits. Number 5 would be the power rule. What happens if you raise a function to the nth power? So this is not just x to the n. This would be something like 2x plus 3 raised to the nth power. Okay, so like 2x plus 3 to the 5th. What do? Well, you find the limit of 2x plus 3, whatever the limit of the inside is, and then you raise it to the power. So find the limit of 2x plus 3, and then you would raise it to the 5th power, whatever that is. So the limit of a function raised to a power is the limit raised to the power. Well, again, that power can be anything we want. So it could be whole numbers, but in particular, it also could theoretically be a fraction. Fractions would be radicals, roots, right? So on that one, I would say the limit of that gives us number 6. The limit of the root of a function is the root of the limit. The limit of a root of a function is the root of a limit. Again, you have to presume here that the limit exists. In other words, you can't be taking the square root of -4, again in this case. So if it's an even root, that has to be a positive, or it could be 0, so it has to be a non-negative number would be the proper way of saying that. Okay. So why do we care about that? What does this let us do? Well, I'm going to write this out in a very expanded form so you could see each and every one of those rules at work. I wouldn't expect you to show all this work for all of these, but I do want you to see those individual rules work in one problem. So no, I don't expect to see all this work on the test, but let me show you how this works. So here's what I noticed. Right now I'm doing a limit as x approaches 1 of 2x squared minus x plus 4. So the first thing I notice is I have 3 separate terms. I have a subtraction and an addition between them, and the beauty of the addition and subtraction property is rather than finding the limit of 3 terms, I could find the limit of each one of these terms individually. In other words, I could separate this as the limit as x approaches 1 of 2x squared minus the limit as x approaches 1 of x plus the limit as x approaches 1 of 4. So I could separate it and find the limit of each one of those terms individually. So that's using the addition and subtraction rule. Now what can I use? Well, here's a constant times x squared. It's 2x squared, right? That's a constant. And what can we do with constants according to the constant multiple rule? I can pull that out in front. So this is really 2 times the limit as x approaches 1 of x squared minus the limit as x approaches 1 of x plus the limit as x approaches 1 of 4. That's using my new rules. So I used addition and subtraction to separate it. I used the constant multiple rule to pull that 2 out in front. Now I can just go here and I can use all the rules that I learned on the previous page. So one of the rules was the limit is x to n. Well, look, you can just plug in that number. So this would really be just 1 squared, which is 1. We learned that the limit as x approaches 1 of x, for just x, again, it's just the numbers, so that would be a 1. And then we also learned that the limit of a constant is the constant. So the limit as x approaches 1 is 4. Remember, this is like y equals 4, so no matter what your x value is, your y value is 4. So that would be 4. So let's put that all together. We did 3 simple limits from the last page. This would be 2 times 1 minus our 1 plus our 4. So what's that? 2 minus 1 is 1 plus 4. I'm getting 5. Is that correct? Well, let's see. This is me separating it and breaking it out. What we're going to realize is one of the beautiful things that we can do is we could just straight up plug in this number. How about 2 times 1 squared minus 1 plus 4? And if I do 2 times 1 squared minus 1 plus 4, well, that would be 2 minus 1 plus 4. Again, that would be 5. So we should have the limit as x approaches 1 of 2x squared minus x plus 4 should be 5. If you look on the solutions to this, the solutions actually have a different problem written here. So I want you to be very careful. Notice we did get a different answer than the solutions because the solutions aren't exactly the same as our notes. So I just want you to take note on that for me, okay? So you can see the rules at work in this left version. On the right version, we just simply plugged it in. Which one of those two would I expect to see on the test? Honestly, the right version. I'd just like to see you plug it in. You need to know when you can plug it in and how you can plug it in, and that's thanks to the next problem right here, or the next little formula right here. It says the limit of a polynomial function. So it says for the limit, it says if p is a polynomial function and c is any real number, the limit as x approaches c of p of x equals p of c. For any polynomial function, just plug in the dang number. So what's polynomial functions? Again, polynomial functions are x raised to nice powers, whole number powers, like x cubed, x to the 4th, x to the 5th. They're not things like the square root of x, or x to the 3/2, or 1 over x. None of those are polynomial functions. It's x to positive whole numbers. So if I look at the next function, it says the limit as x approaches -3 of x squared minus 4x plus 5. Well, x squared minus 4x plus 5, that's a quadratic, but a quadratic, because it's degree 2, but a quadratic is a polynomial function. And the beauty of this previous problem is the previous one says, look, as long as it's a polynomial, all you have to do is plug in that number. So what I want you to be careful with, remember, anytime you're plugging in a negative number most especially, but really any number, anytime you're plugging in a number for x, I need you to put parentheses around it. Not only on your paper, but most importantly on your calculator. If you don't put parentheses on there, for instance, negative 3 squared, if you don't put parentheses, you're going to get a negative 9. If you do put parentheses, you're going to get a positive 9. So one of the simple mistakes that students make is forgetting to put those parentheses. So please put those parentheses in there. You put those parentheses in there, plug it into your calculator. I'm getting the limit is 26. So I didn't need to show all the rules. I didn't need to separate here and pull out the constant multiple of negative 4 in front of x. No need. Just go ahead. It's a polynomial function. Plug in the numbers to evaluate.